All right, chapter 2, part 2. Type of chemical bonds. Ionic bonding forms when two atoms are held together by the attraction between opposite charges. Sodium has one electron in valence shell, usually gives up an electron. Chlorine has 7 electrons in valence shell, usually accepts an electron from another atom. Ions charged. Oh wait, this came from the last part. Yeah, okay. I don't think we did double covalent. Double covalent bonds. Double covalent bonding is when two atoms share 4 electrons. Double bonds are stronger than single bonds. Shapes of covalently bonded molecules. All right. So you got A, electron model showing covalent bonds. B is the structural model. C is the ball and stick model. And D is a space filling model. Chemical formulas and reactions. Reactants. Molecules that participate in reactions, shown to the left of the arrow. Products. Molecules formed by reactions, shown to the right of the arrow. Chemical formulas and reactions. Equation is balanced if the same number of each type of atom occurs on both sides of the arrow. All right. An overall equation for photosynthesis, molecular formula for glucose. All right, so reactants is left of the arrow. I'm trying to look on this diagram, but anyways, we got 6 carbons, 2 oxygens, carbon dioxide plus 6 hydrogens. No, 6 water molecules and 6 carbon dioxide molecules turns into glucose plus oxygen. Ooh. Water's importance to life. Life began in water. Single most important molecule on Earth. All organisms are 70 to 90% water. Water has unique properties that make it a life-supporting substance. Properties stem from the structure of the molecule. The structure of water. Polar covalent bond. Atoms do not share electrons equally. Oxygen is more electronegative than hydrogen. Electrons spend more time around the oxygen nucleus than the hydrogen nuclei. Oxygen becomes slightly negative. Hydrogens become slightly positive. Not an ionic bond or ions. Hydrogen bond, slightly positive hydrogen of one water molecule attracted to the slightly negative oxygen in another water molecule. Properties of water overview. Solvency, cohesion and adhesion, high surface tension, high heat capacity, high heat of vaporization, and varying density. Properties of water solvency. Water is a solvent. Due to polarity and H bonding, water dissolves many substances. Hydrophilic molecules attracted to water and hydrophobic molecules not attracted to water. Water causes sodium chloride to dissociate. The salt sodium chloride dissociates in water. Cohesion and adhesion of water molecules. So here's a little diagram. Adhesion of water molecules helps prevent backward flow. Water transports vessel, blood vessel. Cohesion of water molecules allows for a flow. Properties of water. High surface tension. Water has high surface tension. Water molecules at the surface cling more tightly to each other than the air above, mainly due to hydrogen bonding. Property of water. Heat capacity and heat of vaporization. Water has high heat capacity. The many hydrogen bonds linking water molecules allow water to absorb heat without greatly changing its temperature. Temperature of water rises and falls slowly. Heat of vaporization takes a great deal of energy to break H bonds for evaporation. Heat is dispelled as water evaporates. Properties of water: varying density. Ice is less dense than water. Unlike other substances, water expands as it freezes. Ice floats rather than sinks. It makes life possible in water. Ice acts as an insulator. Properties of ice. Look, ice, lattice, liquid ice. Yeah. Acids and bases. Water dissociates into equal number of hydrogen ions, H plus, and hydroxide ions, OH negative, minus. So here's a little diagram at the bottom. And acidic solutions: lemon juice, vinegar, and coffee. Acids release hydrogen ions or take up hydroxide ions. Basic solutions: milk of magnesia and ammonia either take up hydrogen ions or releases hydroxide ions. So acids, they release hydrogen ions, they take up hydroxide, and basic, they take up hydrogen ions and release hydroxide. pH scale, pH and pH scale. And here's a zoomed in part of that. 1, 2, 3. Okay. And now we're reading the information. Mathematical way to indicate the number of hydrogen ions in solution. pH scale ranges from 0 to 14, as we can see here. pH below 7 is acidic, more hydrogen than hydroxide. So that would be that would be everything before 7. Everything above 7, which is everything that's at the bottom, more hydroxide than hydrogen. And then pH of 7 is neutral. So it is neutral. Hydrogen is equal to the hydroxide. I don't know why that took me so long. And the last slide, buffers in pH. Chemical or combination of chemicals that keeps pH within normal limits. I think that's the definition for a buffer. Resists pH change by taking up excess. pH of blood is about 7.35 and to 7.45 and is maintained by buffer. Diseases such as congestive heart failure and diabetes can result in acidosis. Body can't buffer extra hydrogen ions. Left untreated, death can result. All right.